The Porsche Taycan is one of the most impressive feats of automotive engineering on the road today. And I am here in Stuttgart, Germany to talk to Porsche about this vehicle to find out how they took it from very good to very, very good with the latest update. The vehicle has a larger battery pack, it has more range, it charges quicker from an already impressive 270 kilowatts, and it does all that while being lighter. So how is the Taycan able to pull all this off? Well, I'm here with Klaus Reichberger. You're a director of powertrain for this vehicle. You're in charge of the powertrain, you're in charge of the battery. The Taycan was a great vehicle. Tell me the process to make it what it is today.
Yeah, when we launched the first Taycan, we were very proud of it, and of course, after 3 years, we had to bring some new ideas into the vehicle. So we increased power, we reduced charging time, and we also increased, of course, the range of the vehicle, which are the most important points in the electric vehicle. And power, of course, is Porsche-like. And not only power for the drives, but also bring it to the road.
So one of the more impressive changes to the new Taycan is the increase in power. This is a 24% increase from a vehicle that was already really powerful. So talk us through what you and what Porsche did in order to generate that much energy.
Yeah, I think the power increase in total is even more than 24%, but on the rear axle it is 24% up to 450 kilowatts.
Wow.
The electric motor was completely new designed, so we did the new magnetic design. So we changed the V-shaped magnets, we changed the metal sheets, and we changed also in the magnets. They were separated from each other to reduce the losses. These were the main changes in the electric motor. Then of course we did also some software changes in the inverter. So the PWM, the pulse width modulation, was changed. So the philosophy was to even get more out voltage, so that we changed the modulation strategy. And this was to increase power and to reduce losses. We also adopted the frequency of the pulse width modulation according to the speed of the motors. So if it is a low speed, we also do low frequency switching. And this was done with a lot of improvements, so that we also did so-called frequency wobbling, so that it was not always the same frequency but changed slightly, in order to reduce the noise which is coming out. And with, let's say, a sort of measures, we could increase the total power. Wow. And also reduce the losses and the weight, which is a very important issue for Porsche.
So lighter, but also quicker.
Yes.
So extra quicker. The frequency, like previously, was it like the same frequency regardless of how quick the motor was turning?
Yeah, it was the same frequency, and now we changed it so that at low speed we reduced it to 4 kilohertz, and according to the speed of the vehicle, then we increased, and so that we get out maximum power with reduced losses.
One of the more interesting aspects of the Porsche Taycan is the fact that it has a 2-speed gearbox. Most EVs have a single speed. And what's great is that when you're driving, you can actually hear and feel the second gear kicking in. Can you talk a little bit about the philosophy of adding that to this vehicle, whereas everyone else essentially has a single speed gearbox?
Yes. When we first launched the first generation of the Taycan, we have seen that the 2-speed electric motor allows us to have on the first point maximum acceleration at low speed. and very high efficiency at high speed. Though it's, let's say, of course, a two-speed gearbox is more complicated. So you have to manage the switching and the gear changes and this stuff. But especially for efficiency at high speed and to get the range of the electric vehicle, we had chosen this efficiency for high speed and maximum acceleration at low speed. And that's all behind this. And of course, we also improved it in the second generation now. We reduced friction, but only slight changes. But as you know, Porsche is always, it's our stuff, always to find where we can go to the edge.
Yeah, to the next level.
Next level, yeah.
Well, initially, was there an idea to use a single speed, or was it always a two-speed?
Yeah, of course, we did some investigations also in the single speed when we started, but this is a long time ago.
Yeah.
Let's say it was a decision which was really made very early. And we have seen that with this decision, we can make a typical Porsche, electric vehicle with a Porsche. This is the main idea behind all this.
Let's dive a little deeper into the motor. Let's talk about the hairpins. Typically people are using rounded hairpins. You're using rectangular hairpins. What is the technical reason for that?
The electrical engineers, they designed, the target is always to get as much copper as possible into the nuts of the electrical machine. And that was the decision and the reason behind the rectangular hairpins, so that with this shape of the copper wire, we could increase the copper filling in the slots of the electrical machine. And this is also a point of maximum power and reduced losses. So the slots has to be filled as full as possible, and with this rectangular shape, this was the reason behind.
So it's mostly
the electrical machine.
Cram as much copper as you can.
As much as possible into the slots of the electrical machine.
One of the more exciting aspects of the first generation Taycan was repeat performance, the ability in an EV to keep doing the same thing again and again and again with nearly the same amount of performance. How have you increased that in this generation vehicle?
We increased this in the way that we reduce the losses, so that if we don't produce any heat in the electrical machine or in the battery, we do not have to get it out. And so that all components kept cool, or the thermal management, and together with the increased efficiency and the improved thermal management, we could also increase the repeat performance. And repeat performance is Porsche. You have to do it again and again and again, and not only once or twice, again and again. That's our target. And with these measures, let's say, improving efficiency and also improving the thermal management, we achieved this target.
What's interesting is in the vehicle as a driver, you can see like the battery temperature and all these other things. These are things that most EV makers aren't sharing with the drivers. Is this just part of Porsche's DNA?
Yeah, I think a lot of our customers, let's say, they are technically interested. And so we have also a lot of instruments in our ICE vehicles where you can see oil temperature, you can see the speed of the engine. And I think our customers also want to know what is with the vehicle. How does it work? How does it feel? How can I know what the vehicle is now capable of doing it? And that's why we inform our customers about this. Yeah, they like it, to be technical in the vehicle. Not only passenger, but in the vehicle. That's our, let's say, philosophy behind this. Yeah.
So one thing that people probably don't think about as much as they should, and especially when you're traveling, is charging rates. You know, how quickly can your vehicle charge at peak performance? And the Taycan, you've increased it. It was already a pretty high number. Tell me a little bit about like what you've done to increase it and how you were able to do that.
Yeah, okay. From the beginning, we started with 800 volts. This was, of course, the main step, let's say, in the next level of charging. And so we started with 270 kilowatts with the first generation, and now we increased it up to 320 kilowatts. And even for, let's say, a wider range of for the state of charge, up to, let's say, 50, 60 kilowatts, and then slightly reducing the power. Of course, for the customer benefit out of this is to reduce the time for charging, so to have a longer, better traveling distance, and this was behind the idea, and also, of course, competitiveness. We've seen that competitors are coming up, and we like competition, so we want to be better. And yeah, with the new battery, on the one hand, the new battery was with increased energy, and also reduced resistance inside, so the losses, the heat which is produced out is reduced. We improved the thermal management, on the one hand getting out the heat of the battery, and also getting out of the vehicle. And of course, we improved chemistry. Chemistry, let's say, we did a lot of effort, investigation, how can it be achieved so that we get, let's say, on the limit of the battery.
Yeah.
And we learned a lot out of the first generation. So the first generation was not on the limit, so we could learn about and improve and increase the power with this.
And then that you also increased the range. So with all this, you've also added more range to the vehicle.
Yeah, the range, I'd say one first point is, of course, to increase the energy of the battery by coming from 94 kilowatt hours going up to 105 kilowatt hours. Of course, one of the main points, but not only putting energy into the vehicle, but also improving aerodynamics. Improving electric motors. We discussed also these points about. So we reduced all points where we have losses in the vehicle. We reduced this, and of course we increased energy of the battery. And out together with all these measures, which is a bundle of measures, we could increase the range of the vehicle, which is also the most benefit point for our customers. So get it coming with the first generation, and now with this facelift, I think we did really achieved a good job with this car. Yeah.
The decision to have an 800-volt architecture, how did that come about?
Yeah, when we started, let's say 2015, to think about the architecture of the new Taycan, we thought about increasing voltage in order to improve the efficiency on the one hand, but the main issue was to reduce charging time, because this was always in mind of the customers. Electric cars, it takes a long time to charge, so that traveling from A to B takes a long time. And so we thought about increasing voltage so that we could reduce charging time. But it was not so easy to start this, because our competitors had 400 volts, and most of our suppliers also stick to 400 volts. And so we had to do a lot of work to convince our suppliers that they had to go, that they should go the way with us. And I think, yeah, it was a good decision to go this way. And now we see that there are a lot of competitors coming up with 800 volts, and I think we get a new standard with 800 volts. And this, we are very proud of this.
So, second generation Taycan, I know it's early to start asking about this, but third generation Porsche, the future of electrification for Porsche, electrification is exciting. And are you already thinking about the next generation?
Yes, of course, we are thinking about the next generation. Now we have launched, let's say, the second generation, which is not only a facelift, but really made a new statement. And we are now thinking about the next generation. We let's say, have the challenge accepted. Competitors are coming up. We like competition, and that's why we are thinking about, of course, fast charging. We are thinking about electrical drives improvement and all this stuff, also aerodynamics. All this stuff are in our mind to be improved. And I think we can hardly wait how to bring out the new ideas onto the road and show our customers what we are thinking about. Yeah.
Cool. Thank you so much, Klaus. For more videos about electrification, sustainability, batteries, and of course Porsches, be sure to subscribe to SAE International.